Hello viewers, in today's session we are going to discuss another important problem from application of derivatives, and here we are going to discuss this problem which is related to the concept of increasing and decreasing functions. So here we have to show that the function f of x that is equal to 3 times cos square x minus half is decreasing on this interval, that is 0 to pi by 2, right? So here again we'll take help of the concept of derivative, right? Now see, we know that a function say y is equal to f of x, which is defined in some domain say d, and if this function is continuous and differentiable in some open interval, right? Suppose this function is continuous in some interval a comma b and differentiable in the open interval a comma b, then this function is said to be a decreasing function if dy over dx is less than 0 for all x belonging to the interval say a comma b, right? So if the derivative is negative, that is less than 0 for all x belonging to this interval, then the function is said to be a decreasing function for all x belonging to a comma b, right? So here we'll apply this concept to this function. So let us first find out the derivative of this function. So f prime of x is given by d by dx of 3 times cos square x minus half, right? And here it is important to note that the domain of this function is the set of all real numbers, right? So here x belongs to the interval, the set that is r. So here the derivative of cos square x is 2 cos x, and then by chain rule we have here minus sine x. The derivative of cosine x is minus sine x, and the derivative of here half is 0. So here we have minus, and then we have 3, and we can now write 2 sine x, and here we have cos x. So now from trigonometry, we know that sine 2 theta is equal to 2 sine theta cos theta. So we can now write here sine 2x. So the derivative of f of x is given by minus 3 times sine 2x. So now if this function f of x is to be a decreasing function, then the derivative, that is f prime of x, should be less than 0, right? But here we have a negative sign, that is we have a minus 3 sine 2x. So here we are concerned with only the sign. So here we have the negative sign. So f prime of x should be less than 0 for f of x to be decreasing. So it implies that sine 2x must be greater than 0, or sine 2x should be positive, right? Because when sine 2x is positive, then f prime of x is given by minus 3. So here we are considering only the sign. So we have here the negative sign, and then if sine 2x is positive, then the product of negative and positive is negative. So in that case only f prime of x is less than 0. So now let us consider the sign of sine 2x in the interval that is x belonging to 0 to pi by 2. So x belonging to 0 to pi by 2 implies that we have x greater than 0 but less than pi by 2. So now here we have 2x, and we have to determine the sign of sine 2x. So let us multiply this inequality throughout by 2. So here we have 0, here we have 2x, and here 2 and 2 get cancelled, so we have pi. So now 2x lies in the interval that is 0 to pi. So if we see the sign convention of sine function in the four quadrants, here we have 0, here we have pi by 2, here we have pi, this is 3 pi by 2, and here we have 2 pi. This is first quadrant, this is second, this is third, and this is fourth. So when x belongs to 0 to pi by 2, then 2x belongs to 0 to pi. So we have to consider only the first quadrant and the second quadrant. So we are in the first or second quadrant, and from the sign convention of sine function in the four quadrants, we know that sine function is positive in the first quadrant and in the second quadrant, and it is negative in the third and fourth quadrant. So now we can conclude that sine 2x is greater than 0 when 2x belongs to 0 to pi. That is, sine 2x takes the value either in the first quadrant or in the second quadrant, right? So here the angle that is 2x belongs to 0 to pi. So sine 2x is greater than 0. So now here sine 2x is greater than 0, that is it is positive, and here we have already a negative sign due to the derivative, and the product of negative and positive is negative. So f prime of x is less than 0 for all x belonging to 0 to pi by 2, and it suggests that this function f of x is a decreasing function or a strictly decreasing function on this interval 0 to pi by 2.